Welcome back to our Algebra 1 series. Today we are up to section 7.2, where we'll be discussing compound sentences. Let's say we have a sentence like this. X is greater than negative 2, and x is less than or equal to 7. The word and makes it a compound sentence. This particular compound sentence is a conjunction. A conjunction of two statements is formed by connecting them with the word and. A conjunction is true when both statements are true. Here's our good friend, the number line. Let's look at the first statement. X is greater than negative 2. We draw a line starting at negative 2 and going up. It is greater than. There is a hollow circle because x is greater than negative 2. It is not equal to negative 2. So negative 2 is not included. That's why I draw a circle around it. Let's put down another number line and look at the second statement. X is less than or equal to 7. So here we have a solid circle filled in at 7 and then an arrow going to the left because it's less than or equal to 7. Because it's equal to 7, we fill in the circle. The graph of the conjunction is the intersection of these graphs. In other words, the intersection, where two things are common, would be the conjunction. So to graph it, we need another number line. Let's put down a third number line here. This purple line is the conjunction. It's where the two statements are true together. X is greater than negative 2 and x is less than or equal to 7. So the purple line with the hollow circle on negative 2 and the filled in circle on 7 is the graph of this conjunction. Usually in your math books, you won't see it written out with the word and. You'll see x as an inequality to two elements like this. We know that x is greater than negative 2 and x is less than or equal to 7. The statement on the right is saying the same thing mathematically as the sentence on the left. Just like last section, this is an intersection of these two statements. It's only true where the two lines happen to overlap. So both statements have to be true for the conjunction to be true. This gives us the intersection, or the purple plot, on the third number line here. Let's jump over to the whiteboard and do a quick example. So we're going to write down something like this. We've got negative 3, x, and 6. So what this is saying is x is greater than negative 3 and x is less than 6. So we could write it out as a sentence, but this is the mathematical equation of writing it. So we're going to simplify it and do it this way. We have two statements that need to be true for this entire statement to be true. Negative 3 is less than x, or x is less than 6. We're going to get fancy here and use some different colors. So let's look at the first one. X is greater than negative 3. So we're going to use this first line here. X is greater than negative 3. So here's negative 3. Because it's not equal to 3, we know we don't include 3. So I'm going to draw a circle around it. X is greater than 3. So for this statement alone, the graph would look like this. And it goes on forever. Let's look at the second statement here. X is less than 6. So it's just this we'll do in green on this line. So where's 6? 6 is here. Now it's not equal to 6. We know it's less than 6. We have to draw a circle. We don't want to include 6, but we know that it's less than 6. So it's all of this. It's less than 6. So where is this statement totally true? It's only true at the intersection of the red and green graphs. So we know it's going to be between negative 3 and 6. So where do these two lines overlap? It's greater than 3, so we know we have to draw a circle. And it's less than 6, we have to draw a circle, and it's in between those two. So it's this graph here. I'm just kind of drawing above the line to show. There's no arrows, it's only between these 2 points. Does not include 3, does not include 6. Let's clean this off and do a different kind of example. Alright, we're going to start with the mathematical equation up here. We're going to say negative 6, 2x plus 4 less than 10. So we've kind of got some algebraic looking stuff in here, but let's break it down into what this really means. It means that 2x plus 4 is greater than or equal to negative 6. That's one statement. And second statement is 2x plus 4 is less than 10. So let's simplify. Let's write out those two statements first. So we can write the first statement, negative 6 is less than or equal to 2x plus 4. So we can still solve this, with normal algebraic means. Even though we have an inequality, you can still treat the two sides of the equation as the same. So we can subtract 4 from both sides. This gives us negative 10 is less than or equal to 2x. Now we can divide both sides of the equation and say that negative 5 is less than or equal to x. So we have one part of the statement figured out. Let's do the second one down here. We know that 2x plus 4 is less than 10. Again, we have an inequality. We don't have an equal sign, but we can do things to both sides of the equation to keep it happy and balanced. So we need to subtract 4 from both sides, and that gives us 2x is less than 6. Divide both sides by 2 to give us x is less than 3. So we have our two statements here. We could write them out as a sentence. Negative 5 is less than or equal to x, and x is less than 3. Or we can combine it into the fun algebraic way, which looks like this. We take the far left, negative 5. We know that's less than or equal to x, right? And x is less than 3. Less than 3. So now we've simplified it here. And this marker's dead. Get out of here. Oh, no, new fresh marker. Let's draw a quick number line down here. I'm going to do it freehand. Oh, I got a nice new marker. Just kind of marking off some tick marks here to visually graph this inequality. Let's put 0 here. 1, 2, 3, 4, 5, 6. And do negative numbers the other way. 4, 5, and 6. Okay, that's a 1, I promise. So let's look at the two statements individually. X is less than 3. Okay, so we know it doesn't include 3. So x less than 3 is everything to the left of this circle. But we know that x is greater than or equal to negative 5. So because it's equal to, greater than or equal to, we get to put a solid circle right here. So now we've got kind of our bounds, our lower bound and upper bound. So if I were to color this in, all right, I'm going to make it a big fat line. Right? This would be the answer. This graph from negative 5, including it, all the way up to 3 with a circle around it. It's kind of hard to tell, but that's a hollow circle there. So what about this compound sentence? X is less than negative 3 or x is greater than 5. This is what we call a disjunction. A disjunction of two statements is formed by connecting them with the word or. A disjunction is true when one or both statements are true. So we have our three number lines again, and let's look at the first statement. X is less than negative 3. Again, we use a hollow circle at the negative 3 point because we do not include negative 3. For the second statement, x is greater than 5. We put a hollow circle around 5 as our starting point and go higher because it's greater than. The third graph would be where either statement is true. This is very similar to the unions we looked at in a previous section. We're going right back to the whiteboard to do some more quick examples. Okay, we're going to write the statement up here that x is less than or equal to negative 1, or, that's the important word, x is greater than 4. Now there's no fun mathematical way to do this where you can smash it into one phrase because of this or. So I'm going to hand draw another number line. It's not super straight. And not super evenly spaced either, but you get the point. We'll do 0, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5. So I'm going to use this red marker to show where the disjunction is, where either of these statements are true. Because we have an or, they don't both have to be true. So let's say x is less than or equal to negative 1. So because we have the equal sign, we put a full circle, and then we go less than forever. And x is greater than 4. Because it's not equal to 4, we have to avoid 4. So we draw a circle around it, and we go greater than. So it looks kind of weird that we have this empty space in the middle, but this graph is the disjunction of these two statements. And that's for the new material. If you'd like to see more examples, stick around. Okay, we're going to write a sentence up here that 4 is less than x and x is less than 9. So this is a conjunction because of the word and. So both of these have to be true. We could rewrite this as 4 is less than x, which is less than 9. These mean the same thing. Because this is all smashed together, this statement here and this statement here have to be true, which gives you this and makes it all a conjunction. So we're going to draw another number line here. And I'm going to cheat just a little bit. And we know that x is greater than 4 and less than 9. So I'm going to put 4 here and 9 out here. So it's greater than, but not equal to 4. So we have to put a circle, and it's less than, but there's no equal sign. So again, we have to avoid 9, we have to avoid 4, because we know that it's greater than 4 and less than 9. So it can't be 4 and it can't be 9. But it's greater than 4 and it's less than 9. So it's this space on the number line between those 2 points. We're going to do another one of those algebraic-y looking ones. 7 is less than 2x plus 5, which is less than 17. So don't get overwhelmed when you see something weird like this. Don't think that this belongs together and these belong together. This thing in the middle is the important part. So let's look at this greater than this. We're going to write this out kind of going backwards into 2 statements. So the first statement would be 7 is less than 2x plus 5. We have an inequality, but we can still treat it like an algebraic equation and simplify and reduce and all that fun stuff. So let's take 5 from both sides. So we have 2 is less than 2x. I just subtracted 5 from both sides. Now I can divide both sides by 2 to get 1 and x. So x is greater than 1. So we've got one part of the puzzle. Let's put a little circle around it. Let's look at the second part. 2x plus 5 is less than 17. I can probably squeeze this in over here somewhere. 2x plus 5. This new marker is starting to disappoint me. It's less than 17. I'm going to subtract 5 from both sides to have 2x 5. That makes it 12. Divide both sides by 2. We get x is less than 6. So here's our other statement. So now we could rewrite it in the fancy smashed way. We know that x is greater than 1, but 6 is greater than x. So this would be written as 1. X is greater than 1, yep. And this is less than 6. So we could do the same thing. I'm going to draw a cheap number line here. 1, 2, 3, 4, 5, 6. I'll even write the numbers out this time. 1, 2, 3, 4, 5, 6. And number lines go on forever. Even put a 0 for fun. So we know x is greater than 1. So it starts at 1, but we have to avoid 1 because it doesn't include 1. And 6. So it's very similar to this problem, but it goes from 1 to 6. And I'm just making this big and fat so you can see where the graph would end up between 1 and 6. Let's clean this off and look at some disjunctions. Alright, let's start with something pretty simple. We're going to write it out as a sentence because we have to, because it's a disjunction. X is less than negative 1 or x is greater than 2. So we have 2 statements. As long as either one of them is true, the graph or the resulting picture that we draw on the number line is true. So let's just draw a quick number line here. We're going to go from Negative 3, 2, 1, 0, 1, 2, 3. Negative 2, negative 1, 0, 1, 2, and 3. So we know that x is less than negative 1. So here's negative 1. Let's get some other colors. We'll do this in red. So we know it's less than negative 1, so it's not equal to negative 1. So we have to avoid negative 1 and go less than. But x, or where x is greater than 2. So we're going to go like this. We're going to avoid 2 and go greater than. Now just as a quick example, if this was x is greater than or equal to 2, this marker, then we would fill this in, because then we would include 2 in our graph. Let's do one more before we call it a day. I'm going to write x plus 1 is less than or equal to 0, or x minus 6 is greater than 3. So it's like before, we have kind of algebraicness going on, but we can still simplify. Even though we don't have an equal sign, we have an inequality, because we have greater than or less than signs, but we can still apply the same algebraic fundamentals. So we can get x by itself by subtracting 1 on this side. So x is less than or equal to negative 1. I just subtracted 1. And looking at this one, we would add 6. So we can say x is greater than 9. So we're going to draw another number line here. I'm going to make it big. Some arrows. And we'll start with negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Let's just remind ourselves that this is actually an or. If the marker would work. Or. So where on the number line are either or both of these statements true? So x is less than or equal to negative 1. So negative 1 is included. So we say less than. So we go less than. And the other statement, x is greater than 9. So we have to avoid 9 because we know it's bigger than 9. And it goes like that. And that's it for today. We'll see you next time.